What's happening there, YouTube? Genji here, and welcome back once again to Arcadia 7, where I have been doing some rail science behind the scenes. What I mean by rail science? Well, let me show you. To help explain, let's take a look at my sample 1 rail setup here. So unlike in games like Foundry or Satisfactory, where your manufacturing buildings expect you to pre-sort items on belts before delivering those belts into the inputs of those buildings, because they only expect one type of item on the belt, rails in StarRupture actually work like a network. So as long as there is a valid path of rails from one output to one input, the drones that travel along the rails will automatically pick their route from their source to their destination. This also means that any number of outputs can be connected to any number of inputs along the same rail, and the drones will all share that rail space to reach their destination. However, this does quickly run into a throughput issue where multiple items traveling on the same rail will create a traffic jam as they compete for rail space to reach their destination. So here's a quick example of that. I have titanium, wolfram, and calcium ore all combining onto a single rail to be delivered to their smelters. However, we quickly reach a congestion point here where all 3 of these storage depots are competing to get their materials onto a single rail. And then we have the same in reverse, as all 3 of these smelters are competing with rail space to get their products back into these depots at the far end. This can be somewhat alleviated by unlocking multi-rails. However, multi-rails still act as 3 independent rails that need to be joined with rail modulators in order to facilitate flow of items from one rail to the other, or from one rail to an exit point from the rail network. So you run into the same traffic issues where items are going to bunch up at junction points in order to cross from one rail to the other, or to cross from one rail to exit the rail network. So next, let's take a look at my breadboard layout from the last episode. This essentially combined a row of storage depots with a row of manufacturing buildings, kind of sandwiched together with a row of freeform, reusable connection points that can be used to bridge any arbitrary storage depot through a rail connector or a rail support into the manufacturing building and then back across again to another storage depot. This worked for about 3 rows of manufacturing before I started to run into an issue where we did not have enough output nodes from our storage depots for early level materials to feed all of the downstream manufacturing buildings. So somewhat alleviated by using rail modulators on the manufacturing side to split the incoming lines of, say, titanium bars to go into multiple manufacturing buildings that use titanium bars. However, if we need titanium bars again further down the line, we've already utilized our one connection point for titanium bars from the storage depot to this line of fabricators that are all using titanium bars. So I would have to start putting in multiple rail modulators along our breadboard path, which quickly became messy and just generally untenable. So between episodes, I put together this concept for a breadboard Mark II, which uses mostly the same idea, except we now have a different and slightly wider breadboard section here in the middle, where instead of having a fixed set of multi-rail supports that go from left to right across the divide, the multi-rail supports in Mark II now run downstream the length of the manufacturing pipeline, and more importantly, each of the outputs of the storage depots now hits a rail modulator before entering the connection board. This allows us to use rail modulators both on the output side and on the input side to increase the availability of each material in the network. However, this layout quickly begins to fall apart as soon as we hit furnace manufacturing, which can require up to 3 independent inputs of its own, which will entirely saturate a multi-rail support or a rail modulator, thus eliminating the advantage of having multiple manufacturing plants on the same row, making it impossible to extend if we need to increase manufacturing capacity, and just generally requiring too many rail interconnects, which very quickly saturate the available space in the breadboard section between both sides. But since I went through the trouble of building it all, I do at least want to see it all running, so I hooked up all 3 of the incoming resource lines, which run into 3 smelters, which run into 3 storage depots, which feed into fabricators, and so on and so forth. So now the whole system is alive and abuzz with parts, and it looks like we have almost gotten to the furnace. I see some parts moving into the furnace. It's just fun to watch all the little hamster wheels turning, and it's one reason I like the singular input lines to like a reusable bus, because you get all of these very interesting looking kind of circuit board layouts that are a lot more visually interesting to look at than just like a main bus like we had in Foundry, where it's just a tower that's 27 conveyor belts tall. Oh, and here we go. The furnace is officially operating and delivering our final product, which I believe was titanium housings. At any rate, let's take a look at our next plan. Speaking of walls of conveyor belts, here's a prototypical cross-section of my idea for a main item bus here using rails in StarRupture. The idea is that there are 47 manufacturable items in StarRupture across all the different manufacturing buildings, which means that in order to have each item available at any arbitrary points along the bus, we have to have 47 individual rails that all run together and can have items either pulled off the bus or put onto the bus onto their assigned rails. Now, this is not 47 rails, this is 21 rails, but the idea is the same. In order to pull an item off of the bus, we need a rail connector that is lower than the height of the bus so that we can pull a rail off, go underneath the main bus, off to the side where we can reconnect it up to a multi-rail connector that can then feed into our manufacturing plant, into a storage container for buffering, and then back underneath our main bus and up onto the rail that's going to be assigned to for the rest of the main bus run. Now, the main drawback of this main bus layout is that each of the 47 rails on this main bus are going to require its own individual manufacturing stop. So basically, this kind of cutout, but repeated 47 times with a different manufacturing setup on each stop in order to manufacture a different item. However, the nice part is that it should be theoretically infinitely extensible. So, for example, if we need more titanium rods down the line in order to meet demand, all we have to do is add a second fabricator, split our output from the main bus of titanium bars with rail connectors, and then rejoin the output of our second fabricator back into the output of the first fabricator, and then into our storage depot for busing before going back into the main bus. And we can do this any number of times as long as we have space. However, just judging by any particular arbitrary direction, we're not going to have enough space to repeat this pattern 47 times, which means at some point we're probably going to have to turn or maybe U-turn and bring this main bus back towards itself. But one way or another, I think we'll definitely be able to make enough room to repeat this layout. However, like I said, this is not 47 rails. This is 47 rails. This is 16 multi-rail supports stacked side by side with the same amount of space in between each one as we saw in our previous setup. So this will have to be repeated 47 times, each gap here with its own manufacturing setup branching off from it and then extending off into the distance. But again, the main downside of this main bus layout is the immense amount of space that's required. The rails themselves don't require that many materials, and because we have in our breadboard Mark II layout, we are actually manufacturing basic building materials. So we have a essentially unlimited supply of those now. We don't have to keep hand making these. So we shouldn't have any issues actually constructing the rails. It's just going to take time to actually build a 16 wide main bus all the way across the landscape and to find enough empty space to actually wind this through to fit in 47 of these individual structures. However, I think this is the plan we're going to try to go with from this point forward. So let me do a little building montage where I essentially reproduce our manufacturing capacity that we have with our existing layouts into this main bus system, and we'll see what it looks like. So we'll speak back up in just a bit. And so here we have it, the assembly line that can theoretically produce any item in the game, because at any point in the assembly line, it will have access to every type of material that has been manufactured before it in the manufacturing process. I suppose, technically, I didn't have to make this 16 supports wide at the beginning, since we're only going to be using 1 multi-rail, and then 2 multi-rails, and then 3 multi-rails. So we could have allowed this to expand on its own naturally, but I just kind of like the way it looks having a uniform width for the entire main bus. But again, the way this works is that we have 1 incoming multi-rail that has each of the 3 basic building materials on it: titanium ore, wolfram ore, and calcium ore. And then one by one, each of these is plucked off of the line, hits a rail connector to be split off into the smelter, while 1 rail continues forward on down the line. Then from the smelter, it spits out into a storage depot, and then from the storage depot, it wraps under the lines to whichever rail support is going to be going on to, and then continues forward. So the way that this is set up is you'll always have 1 rail connector underneath the incoming rail for the materials that you need to pull off of the bus, and then you'll have 2 rail supports for offloading the manufactured item back onto the bus. So you'll have 1 immediately underneath the storage depot to kind of dip the rail underneath the line, and then another one which we don't need here since we're on rail 1, but if we scoot forward into rail 2, we have our second rail connector here on rail 2. And then if we go even further down the line, we have our second connector on rail 3, which is a bit out of our sight at the moment. Let me move up. Here we go. So again, we have 1 rail connector to dip under the line, and then 1 rail connector to get back onto the line to move forward. So each time we manufacture a new product, we're pulling items off of the line. So for example, this is... Now let's use something that needs multiple components. Here we go. So this is a perfect example. Here we have rotors being manufactured in a fabricator, and so rotors require, looks like titanium rods and wolfram wire. So underneath each of the lines that has those 2 materials that we need, in this case wolfram wire, is being pulled off of this line, dipped down on a rail connector. 1 feed goes off to the left to go into the fabricator, and 1 feed goes straight forward to continue down the assembly line, or down the main bus. And then repeated here again for titanium rods. We're pulling titanium rods down into this rail connector, which is actually offset by 1 vertical position from the wolfram wire, so that the wolfram wire can actually pass over the rail connector for the titanium rods. Both of those then feed into a multi-rail, into our fabricator, and then from the fabricator we have 1 rail that runs out into our storage depot, runs underneath the main bus, and then onto a rail connector to feed back up into a new line that then continues on forward. So to give an even better example, let's create a new node along our main bus here, where we're going to manufacture the latest material that we've unlocked, which is stabilizers. These are created in a fabricator. If we visit our fabricator, we can see that stabilizers are going to take rotors and titanium rods. So we'll select stabilizer. And unfortunately, unlike something like Satisfactory or Foundry, where we can actually see which materials are available on each rail, that is not the case here in StarRupture. So I just have a notepad here that lists each rail that we're currently using, and then what item is actually available on each of the rails. So let's extract titanium rods first. So according to my list, titanium rods are rail 1 on pull 3. So that's going to be right here. So we're going to delete this floor tile here, and we're going to put a rail connector here. We're going to offset it by 2 vertical positions here. We're then going to put a multi-rail here at the foot of the fabricator to receive our 2 incoming feeds here from the bus. And we'll take line 1 off of pole 3 for rods. Then feed this into the middle of our multi-rail, and then from the middle of our multi-rail into the fabricator. So that's our connection feed for titanium rods. Rotors are slot 1 or rail 1 on pole 5. So 1, 2, 3, 4, 5.
I'm so hungry I feel sick.
And we'll get to it in just a second. So we'll delete this tile. We'll select another rail connector, and this one will offset by 1. We'll connect this up with a rail. Rail number 1 for rotors. Then we'll go over the top of our previous rail connector into this side of the multi-rail, and then from here into our fabricator. And this should provide this fabricator with rotors and titanium rods. For the output side, we're just going to have a storage depot here. We'll have one rail support here, and then this is going to go on to rail 5. So we're going to go 2, 3, 4, 5. Put another rail connector here. Come on, line it up. There we go. Offset by 1, 2. The same here. A rail support offset by 1, 2. And then connect everything with rails. Sounds like our materials are arriving. And this is going to go on to rail number 3, because we have rotors and tubes on 1 and 2. And the only thing left to do would be to connect everything else forward to the next node, making sure that our rail connector that we use to pull our materials off of the lines gets reconnected back into where that original line would have connected, like so, and like so. And there we go. Now we have our first 5 poles filled up. All that's left to do is to go to our storage depot and tell it to start storing stabilizers. And there's our output from the fabricator. We should see some more materials start flowing from further back in the line. Yep, we can see them moving forward now, and there's our titanium rods. So these should be filtering over here shortly, and we can move on to the next material. Which leads us to our next project for the day. Let's take a look at our recipe list for the fabricator. The only recipes that we have left to unlock for the fabricator are stators, which we don't currently have blueprints for, and applicators, which we currently lack the ability to manufacture glass for. So let's see how glass is manufactured. I'm going to guess it's done in a furnace. Ceramics, glass, here we go. So to make glass, we need an abundant source of helium-3, 2,500 worth, and calcium powder. I believe we can already manufacture calcium powder. I think that is also done in a furnace. Yeah, calcium powder is already unlocked here in the furnace, so we can set that up. But we are going to need a source of helium-3, which means we're going to have to go to our corporate terminal here and see how we unlock helium-3 extraction. So that's our next level unlock in Selenium Corporation. So that's going to require tubes, which we actually have available on our assembly line already. So let's go over to where we're manufacturing tubes, and we can figure out how we're going to set up export from this bus to delivery to the corporations. So since we have a storage depot available for every type of material that we're manufacturing, all we need to do is set up temporary orbital cargo launcher platforms next to, I'm being carried away, next to the storage depot for whatever material it is that we need to deliver. So in this case, we've got a silo full of tubes, a depot full of tubes, so we just need some cargo launchers and then some rail connectors to split our available supply of tubes among the available cargo launchers. So we'll set up, say, 3 for now. I rotated in the wrong way. There we go, now they're facing the right direction. So a rail connector. 1, 2, 3. Connect these with rails. Oh, we're getting that bug again where the rail connection point is actually disconnected from where the camera is pointing. There we go. You have to exit the tool mode and then go back into it to fix it. That's been a bug for a while. I'm kind of surprised it hasn't been addressed yet. We'll feed these through. In this case, it doesn't matter that we're connecting everything with one rail because it's all the same type of material. And these orbital cargo launchers are so slow that we're never going to hit a bottleneck here at the junction points. So we're going to deliver to Selenium Corporation. We're going to deliver tubes. Here come our tubes. We're going to do the same here. And the same here. Now, theoretically, if you wanted to pre-lay out 47 lengths worth of this main bus, You could stick a bundle of orbital cargo launchers, or orbital cargo launchers at the end of the bus, and then simply go to your bundle of orbital cargo launchers, tell it what it's going to be receiving, and then connect a rail from the end of the bus to your OCLs. But I think this is just a much easier solution, since most of the time these are going to be temporarily placed anyway, just long enough to complete the contract. So we're going to need 37,800 of these. This is going to take quite a while, so I might actually split this among a few more OCLs. So let me get that built real quick, just to speed things along. And there we go. Now we have 5 orbital cargo launchers launching tubes into space, which gives us some time to go and take a look at what our next step is going to be. So after this contract is delivered, we're going to have access to Helium-3 extractors. So we're going to need to go and find some Helium-3 nodes, place them, and then run rails back to our main bus here. Now this Helium-3 is going to need to go on a new line, so that will probably be our first rail on pole number 6, so that it's available on the bus. And we'll be able to plug this into a furnace for manufacturing glass, and we'll also need to set up a furnace for calcium powder, which we can actually do already. So while we're waiting for this contract to be delivered, let's set up a furnace for manufacturing calcium powder. So this will actually be the first furnace on our main bus line, but it's going to work the same in principle. We're going to place this one tile forward to give us room for our incoming rail support. Multi-rail. Offset by 1, 2. Let's take a look. Calcium powder should just take calcium blocks. Calcium sheets? Yeah, calcium blocks. So calcium blocks are rail number 3 on pole number 2. So rail number 2, delete this tile. Drop in a rail connector. Offset by 1, 2. Rail number 3. Divert this here, send 1, actually we didn't need a multi-rail support here. It doesn't really matter though. We'll send this directly into the furnace, and then we'll send 1 straight forward. And that handles the input side. From the furnace, we've already selected calcium powder. Now we just need to handle the output side, so we're going to drop a storage depot right here. Delete the first tile, and then this is going to be pole number 6. This will actually be our first rail on pole number 6. So 1, 2, 3, 4, 5, 6. Like so. Rail connector, offset by 1, 2. Rail support, offset by 1, 2. And then connect our rails. There we go. And bring everything else forward again. What, I seem to be experiencing a bit of a bug here, or maybe I don't understand exactly how multi-rail supports are supposed to work. But I have 1 feed of calcium blocks coming into the 3rd rail of a multi-rail support. And I have titanium bars coming along the 2nd rail. And then the titanium bars are just jumping ship from the multi-rail support onto the 3rd rail with the calcium. Actually, everything. Everything is jumping onto the 3rd rail for some reason, even though these are all dedicated 1 item per rail from input to output. They're using this as a rail connector somehow. They're all jumping onto 1 rail. Switching back across rails at the next spot. Like, why is copper... Why on this link is everything moving to the right rail and then moving to the left for the next link? There's something very fishy going on with the networking logic here.
Ruptura activity detected.
And we don't have time to debug it anyway because the Ruptura is here. What on earth is happening? I'm gliding around like a vampire with my arms out. I'm still doing it. I'm stuck in a jump. I'm landing multiple times a second. Stop. Okay, I did a save and reload, and it didn't seem to fix the issue, so I did a little digging around on the forums, and this seems to be a known issue. The developers haven't commented on it, but the consensus seems to be that these are not supposed to work as lane splitters, so this must be some kind of, perhaps, vestigial code that never got pulled out, or just a straight-up bug. But whatever the issue is, there's not currently a solution to it, so I guess we'll just have to live with whatever congestion we get from these materials lane hopping for right now. But as long as our materials are actually moving down the line, if this gets fixed, we won't have to worry about doing anything differently. They'll just work the way that they're intended, because we have them connected the way that they're supposed to be if this were working correctly. And the downstream effects are our furnaces working at least, so we're producing calcium powder, which we can use to begin unlocking glass. And 600. Alright, let's go turn these in, and then we'll work on the helium extraction. Alright, here's our 600 calcium powder, and I pulled all of the helium-3 that we had in storage out, but we're not even a quarter of the way to the 2500 goal here. But I will insert our 400 data points, so we're gonna have to wait at this point for our contract with Selenium Corporation to finish submitting. Then we can take our helium-3 extractor and go pull up some helium-3. So, let's be back up in just a minute.
Ruptura status stable. Congratulations. Selenium received its
And
order.
there we go.
Your reward, as always, is waiting in the corporate terminal.
Let's claim our helium-3 extractor. And let's go take a peek at how exactly we're going to use this. So, extraction, helium-3 extractor. Let's go see... We saw a number of little purple nodes out here amongst the rocks in the ravines here. Let's see if these are helium-3 nodes or if it's something that we have not yet encountered yet. Yeah, I don't actually see any resource nodes here. There's little green or teal indicators that show where extraction nodes are that can have harvesters placed on them, and I don't see anything over here in the caves or the cliffs, so I don't think there's any helium-3 to be found here. So we're gonna have to do a little adventuring and see where exactly we can get this stuff from, because this may be, since this is kind of an unlockable that's higher up the tech tree, this may be something we're going to have to adventure out a little bit to find. So, make sure that we have... I don't have any food on me, but we do have ammo, we have building materials. Let's go on a little adventure. It occurs to me that we're going to need a meteorite core to build a base core for any extractor that we make, so let me just harvest this real quick. Oh, I think we have a winner over here. I am going back up towards the Clay Woods Research Outpost where we've already been to just kind of push into an area we were already somewhat familiar with. And as I crested the hill here... Oh, we have some new things as well. What is this? Serpent root. We got a space onion. I see another cave here. Oh, they grow over. So we were just lucky that we showed up during, just after the Ruptura. Presumably the Ruptura burns away all these vines. Interesting. So we can only visit during certain times. Good to know. But that's not what we're here for. We're here for... Oh yeah, this has got to be helium deposits. It's purple. Can we manually... No, okay. That makes sense. I don't know why you would be able to. I'm not sure why we can harvest helium from a meteorite either. But I'm gonna get this map node while we're here. which we know is a combat challenge.
Geoscanner initialized.
Whoa, 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 whoa. And we're gonna look for clouds. Here we go. Just keep coming. Normally they'll pick a new spot. Guess there's only so many approach angles here. Oh, there they are. Ah, these guys strafe. Alright, now I'm just gonna come over here. Let's talk up close and personal. Let her rip. Now they attack it.
I'm so hungry I feel sick.
Now is not the time. What is going on here? Oh. I didn't know they could do this. It's too hot outside. Seek shelter? What? Are we done? Gimme.
It works.
Oh, this is a new type. It's like a mortar bug. Nasty.
Who's next?
Okay, so what do we unlock? We got a big old scan. We've got another monolith here. Some drone wrecks, some bodies. Underground cave, which we know about. And some kind of interesting material here. But for right now, we need to set up a little base here around these helium deposits, and I guess... Man, it's gonna be a really long rail. I think what we're gonna want to do is research the transport drones that basically aerial launch some materials from a transmit pad to a receive pad. I don't remember the exact name. But we might want to research that rather than send one ridiculously long rail all across the landscape, which is going to require many, many additional base cores to be built along the way, which I don't think is going to really be tenable. So let's plop one of these down here. That's fine. And drop our helium extractors. I didn't check which way this exports from. Let's see. There it is. Let's have that. Let's rotate this, actually. What are you even shooting at? The event is over. You don't have to shoot at the map thing anymore.
That was close.
Was it? Was it really? Let's face this direction. And we'll face this direction. We're gonna need a wind turbine for power. Why am I running around? We've got technology. Is it? How big are these buildings? Wait, that's fine, but that's not? Hey. Event's over, buddy. Where are they all coming from? Okay, I popped every bug that I could find around here. Let's see if they're going to keep spawning or not. At any rate, we're working on power. So, wind turbine here. And how exactly are we to deliver power to these guys? I guess by rail. So let's build a storage depot here. And then we'll connect rail and rail temporarily just to get things moving along, and we can collect by hand. Oh god, they're back again. Can we build a wall to keep these guys out? I don't think we can build walls. I mean, I guess I could build a bunch of pillar supports right next to each other. They only cost 1 building material. There we go. That's kind of a makeshift wall. So we need 2,500 helium-3. I have to, I guess, tell this that it needs to be storing helium-3. There we go. Now it's flowing. We're spitting out pretty purple gas all over the place. So let's also drop a habitat here if we're going to be working on this side of the world. We're going to need somewhere to pop into in the event of a ruptura. Just find a place where we can actually put this. For some reason we can put this here, even though it's going to be halfway inside of a rock. Some windows. And there we go. So let's check corporate terminal. Let's make a recipe station, and let's make a basic item printer. There we go. So, Clever Robotics, I think, is going to have these cargo dispatchers, so we actually need to unlock 2 levels of Clever Robotics, which is going to require heat-resistant sheets and titanium housing. And I believe heat-resistant sheets is going to require us to start manufacturing glass, which is a little unfortunate. Heat-resistant sheet, yeah, we're just going to require glass. So that means we're going to have to temporarily separate our manufacturing, or just deal with doing daily runs to collect helium.
Oh, gotcha.
This game needs a shift click to pull things out of inventories. But we're going to need 25 of these, which is going to be a lot of running back and forth unless I just kind of AFK here for a while and let this build up. In fact, I think that might be a good idea. Instead of having one, let's duplicate this. One, two, we'll do 4. One, two, three, 4. And then I would imagine these are automatically going to load balance. These should flow into here. These should flow into here. We'll set each of these for helium-3. Yeah, they'll flow from one to the other. That way we can stockpile a larger buffer of this so that we can do more than 400 at a trip. Oh, and I see calcium deposits over here. So this is intended because helium and calcium are used to make glass. So I bet you're intended to set up an away base to manufacture glass over here and then send it back to your main base. Hello. What do we have up here? Oh, I think that's a drone wreck. Let me see if I can get to it, though, while we're waiting for this helium to build up. There we go. Alright, what's in the box? A damaged logic board.
Gotcha.
Boo. Yeah, you did get me. Ha ha. Very funny. Alright, there's our pockets full of helium. Just a ridiculous amount of helium. So let's see if we can make it back to our main base before the Ruptura hits. Alright, and back. So, let's drop all this off in furnace, and then glass. Here we go. Insert everything we have. So we're at 1900, pretty close. So the next trip should easily hit our target here, and then we can begin manufacturing glass. Let's also turn in all these biofacts at the scanner.
Useful information.
Claim.
Interesting.
Claim. Claim. Logic board. Drop off some of these consumables. And while we're waiting for helium, let's take a look at what other contracts we can be filling at the moment. So let's start at the top, I guess. We've got the food station from Future Health would be kind of nice. We need ceramics, though. Do we have access to ceramics? That's made in a furnace? So that's made with calcite sheets and wolfram powder. That's easily doable. So let me go collect wolfram powder and calcite sheets from our line. Okay, I ran back over to our helium plant and gathered up another inventory full of helium. So let's hop into the furnace here. Submit the rest of our helium that we need for glass. So we can now manufacture glass in a furnace. So we'll get that set up on our assembly line. But I also have some wolfram powder here for ceramics. We still need another 3 of that. And let me see, is there anywhere I can dump these extra tubes? We do need tubes for inductors, so let me just dump those there. Perfect. So let's get glass manufacturing set up on our line. Even though we don't have helium available yet, we can still hand deliver helium to the furnace so that we can at least start delivering on this contract while we wait. So we're going to need to extend our existing bus. So we're going to stick this out by 1, 2, oh, let's match our height. 1, 2, 3, 4, 5, 6. We're going to go to our minimum possible height and then go up by 2. 1, 2, so that we can then go down by 2 when we need to go under the line. 3, 4, 5, 6, 7, 16. We can connect everything with platforms. Like so. We'll need another furnace facing this direction. And a storage depot. We'll get rid of this staircase. We'll get rid of this tile. And we need to pick a rail that we're going to bring helium in on. Our next available rail is on pole 5. So 1, 2, 3, 4, 5. Rail number, actually pole number 6. Rail number 1. So we'll get rid of this. Right, so the next available rail is actually going to be pole 6, rail number 3. So we're still in the right location. We just need to pull down a rail connector from here on number 3 into here. Connect this to a rail support. Well, let's take a look at what the recipe actually calls for before we make that decision. We're going to be making glass here. And glass takes helium-3 and calcium powder. So we already have calcium powder on the line at pole 6, rail 1. Helium-3 is going to be on pole 6, rail 3. So we'll set this up here. We can manually feed in some helium and some calcium powder. Here we go.
Oh, gotcha.
Just to get things moving. Connect the rest up with some rails here. So this is going to spit out into this depot. This is going to need to be a multi-rail. 1, 2. Although apparently what we've learned today is that it doesn't need to be a multi-rail at all, because everything is getting shunted onto one rail anyway. But we'll keep with the pattern for now, and we'll see if this is something that gets addressed, or if the dev is just going to tell us, nope, this is the way that they're supposed to work, and then we'll have to recalculate how we're doing distribution on our bus here. We're going to feed in 2 of these, because the second... Actually, we need to raise this, because our second... Well, no, we can just go this way. No, this needs to be... This needs to be... Because of the way that these rails are aligned, this needs to be calcium powder, which is rail 1. Drop this by 1. This needs to be helium, which is rail 3. There we go, that connects into there. And then each of these is going to be sent forward, so this will be rail 1. Yeah, rail 1. Rail 2 will connect on through because rail 2 is wolfram powder. And then rail 3 will be you. There we go, now everything is fed forward. I do need to get caught up with our bringing our rails forward. It's a bit stringy right now, but we're in the middle of it. And then, alright, the output side. We need 1 rail support facing this way. Bring it down 1. In this case, that will put it at 2 to the actual rail supports. And this is going to go on to pull 7 now. So we've got 1, 2, 3, 4, 5, 6, 7. So we'll get rid of this stair. Rail connector here. Drop it by 1, 2. Feed this to here. This to here. And then this to rail 1. And there we go. Now we have glass, which you can assign here. That actually has some output here. We are going to need to get calcium powder moved in here, which, even though it should already be on our line right here, calcium powder, I think this may be the buggy rails again. So calcium powder spits out rail support, rail connector, rail 1. Rail 1 is facing in the right direction. Goes to here. Rail 1 drops down. Rail connector facing the right direction. Middle of the multi-rail support and then into the furnace. So we should be getting calcium powder delivered here. But the rails seem to be bugged at the moment, so what I've had to do to fix this, again, is just start removing rails one at a time and reroute them to the same place that they're already going, and then eventually the network will figure itself out. To here, and there we go. So nothing actually changed. We just had to remove and replace the rails to get the network to recalculate, and now goods are flowing. So this is definitely something that needs to get addressed, and as this bus layout gets larger and larger, I think we're going to run into more and more of these bugs. So hopefully this is something that gets addressed sooner rather than later. Otherwise we may have to rethink how we're doing our main bus system. At any rate, with calcium powder being delivered, until we get a solution to bring Helium-3 all the way over from the other side of the map, I'm going to temporarily place a storage depot right here, just so it has power. Feed a rail into the 3rd slot here. We'll assign this to Helium-3, and then I'm just going to dump a bunch of Helium-3 in here. That way we have glass manufacturing going on. Perfect. Okay, so let's go take a look at a console. Alright, furnace. We have our last 3 wolfram powder for ceramics, so we can unlock ceramics. So now we'll need to add a couple more furnaces onto our bus here. One for titanium housing, which we don't have yet, and one for ceramics. So let's keep this design moving forward. Okay, so here's our 2 fabricators and 2 storage depots. So we'll set this recipe for, let's do titanium housing first. We'll set this furnace for ceramics. We're gonna need to bring all of these lines forward now because we do need some of those materials that are not currently brought forward, so let me do that quickly. Okay, now let's look everything up. So, for titanium housings, we're gonna need titanium beams and titanium sheets. Let's get up here. So, titanium beams are on pole 3, rail 3, and titanium sheets, titanium plates are on pole 3, rail 2. So, both are coming off of pole 3. So we're going to get rid of this. We're going to get rid of this. We're going to make a multi-rail support. 1, 2. We're actually going to need to get rid of... Whoops. I always do that. I don't need to cancel all the way out. We're also need to get rid of this because we're taking 2 off the same pole. So rail connector. 1, 2. Uh-oh. I can't go down that far. Stupid elevation changes. That's okay. What we can't do in height, we can make up for in distance. So let's try this instead. So we'll do a rail connector at height, down 1. That's as far as we can go. I broke the wrong one. We want to break this one. And then we'll put this one as low as it'll go. And then we'll take rail 2. Which is titanium plates, titanium sheets. Rail 3 is titanium bars. And then we'll feed these into the multi-rail. There we go. And then into our furnace. Clean this up a little bit. We'll then take the output of the furnace into the storage depot. We'll get rid of this staircase, and this is going to go on pole number 7. So 1, 2, 3, 4, 5, 6, 7. Get rid of this guy. Rail connector, 1, 2. Rail support, 1, 2. Run this under. From here to here, here to... titanium housing is going to be rail number 2. And then we just need to connect these back up. So rail number 2 to rail number 2. Uh-oh, what are we hitting? Ah. Alright, let's see if we can move this forward. I'm actually going to connect this back up first. This needs to go from rail 2 to rail 3. Here we go. We'll copy this. There we go. That works. I just have to move this one, this rail support or this rail connector forward one, just to account for the elevation difference, because we're building up a hill here, which makes us a little bit awkward. But now everything's flowing nicely. And our output is connected from our storage depot back into this rail, so that should all be good. I can't help but notice that the materials have not started flowing yet, which means that we're still bugged. So I'm going to have to find out where the hang-up is for this, but we'll get this moving forward. Okay, here we go. I replaced every single rail, and that didn't fix it, so I just saved and reloaded, and now the resources seem to be flowing. Oh, they are all on a single rail, even though they have their own dedicated rails, so again, the rails are just not working the way that they seem like they should be. Like, I don't know if this is the intended functionality of the multi-rail, or if there's something wrong here, but either way, this furnace is now producing titanium housings and flowing into the storage depot. So let's repeat this for, I don't even remember what we were making here at this point, ceramics. All right, so ceramics are going to be calcite sheets, wolfram powder. Calcite sheets are on pole 4. Let me get into craft mode here. It doesn't matter. So what do we say? Calcite sheet, pull 4. So we'll get rid of this. And wolfram powder is pull 6. So 1, 2, 3, 4, 5, 6. Which means we're going to need to bring these lines forward. No big deal. Let's drop a rail connector 1, 2. Rail connector 1. Calcite sheet rail 3. And wolfram powder rail 2. Then we're going to need a multi-rail support. 1, 2. Bring these into the rails, or on the rails. And up into the furnace. And for output from the storage depot, we're going to need one connector here to bring these under the main bus, and then these are going to go on pole 7. Titanium housing was rail number 2, so ceramics are going to be rail number 3. Rail connector 1, 2. Rail 3. Connect it on through. Oh, I didn't put the rail support here. That's okay, we can do it this way. 1, 2. Then to you. Now, we need to bring these lines forward to actually supply this furnace. And just in general, they need to be brought forward. Like so. Yeah, so then this is going to be number 2, so this can also be brought forward. 1, 2. Here we go. So that's everything, and then these I'll bring forward at some point. But for right now, I just want to, I'm sure, struggle with the rails to get this cooking. So we need calcite sheets and wolfram powder flowing. I don't... oh, this is rail number 3, so this is probably for the titanium housing. Yeah, these are titanium beams. I don't see anything flowing on that rail, so I'm going to save and quit, and we'll see if that fixes it, and if not, I need to start breaking and replacing rails again, so let's see. Okay, furnace is showing awaiting items after a reload, which means that they're on their way. That's good. Saves me the trouble of having to break things. So let's set this to ceramics. And I've actually forgotten what we were doing all this for. I spent so much time trying to troubleshoot these rails, so let me go reground myself here. So we were doing ceramics for future health solutions, right? Ceramics, and then we also need heat-resistant sheets and titanium housing for Clever Robotics to start working towards the cargo dispatcher. We just did Selenium Corporation earlier. The large habitat would be cool, but that requires us to create a completely new manufacturing line. We can deliver Griffith's Blue. We're now making everything that Griffith's Blue wants. Heat-resistant sheets we'll have available as soon as we start making them for Clever Robotics. So let's check heat-resistant sheets. That's going to be in a furnace. So we need 600 wolfram plates, 600 titanium plates, and 200 glass. Well, that's easy because we have all of that in our manufacturing bus already. So let's donate our data points. Let's go hand scoop up some of these wolfram plates, titanium sheets, and glass, and get to the point that we can actually manufacture this. I'm actually going to donate these plates from our existing supply of extras that we picked up. So here's 400. 74 and 17 is not going to be enough. Here's 1, 2, 3. And the rest we can grab from our vestigial leftover silos that I have scattered around from all of our replace manufacturing lines. So we need 600, so here's 5 and 6. And here's 300, 4, 5, 600. Okay, let's drop these off at the furnace. Right here, insert our glass, insert our titanium sheets, insert our wolfram plates, and there we go. Heat-resistant sheets are available. So now we have 2 more tasks at hand. We're going to need to set up some orbital delivery to fulfill our ceramics delivery. So let's get this rolling. Level this here. Set it back. 1, 2, 3, 4, 5 should be enough. And just as many rail connectors. 4, 5. Rails. Nope, the rails are off again. They're down at the base of the rail connectors. So many bugs. This is the bug episode. Alright. 1. No, go. 2. 3. 4. 5. Bring the main line through. Connect the output from the storage depot. And select the contract. Future Health Ceramics. And here they come. Perfect. Alright, now our second task is to set up another furnace for the manufacture of heat-resistant plates. So, before we start that, I'm going to bring all these rails forward, because I'm sure we're going to need some of these materials. There we go. Now we're going to need a new segment. So let's take multi-rails. 1, 2, 3, 4, 5, 6. Actually, we're probably going to have to turn this soon. But since I think this is the last factory we're going to set up for today, we'll set up this one last segment and then I'll turn this in this direction and then we'll actually loop back again. Because we're also, besides running into this canyon, we're also going to run into our feeder line for our basic ores. So yeah, I think this will be a good place to start turning, because it's going to be a pain to get it over this. Right here. Delete 1 square on this side, 1 square on this side, and let's take a look at our recipe. Heat-resistant sheet. Okay, this will be our first 3-ingredient manufacture. So we need plates, plates, and glass. Let's take a look. So, titanium plates are on pole 3, rail 2. So 1, 2, 3. Wolfram plates are pole 4, rail 2. And glass we have as pole 7, rail 1. So 1, 2, 3, 4, 5, 6, 7. And we're going to need a multi-connector facing this way, or a multi-rail. 1, 2. We're going to need all 3 rails connected. 1, 2, 3. And since we can only go down 2, we're going to have to combine height and distance this time. So this will be 1. So let's hook these 2 up. This was our 2 plates. So titanium plate is rail 2. Wolfram plate is rail 2. Oh, I guess I am usually doing it that way, huh? Okay, that's alright. We can adjust. We'll get rid of this. we'll raise it up by 1. So instead of going down 2, we'll go down by 1. Bring this into the left. Bring this straight through to the center. There we go. And then all the way back here, we're going to have to go out by at least, well, 1 is probably enough. 1. Oh, interesting. We can't go down at all. Here we can. Let's see. Can we put a rail support here? We can, okay. It'll all work out. So our glass is on rail 1. That'll go here. This'll, no, actually we need that to go forward, so we'll just go, we'll take this. Go to here. This will go here. And the only thing that's going to potentially geek this up is if this can't go forward. Which it cannot, that's interfering. So let's break this. Let's pre-connect this, because this is going to be... Excuse me. Something that gets randomly get kicked out of drone mode. We're going forward from here to rail 2. So this is what we have to get under here. So can we go forward one more time? Rail support. Can't put it there. Rail support. We can put it there. So this is going to need to go forward to rail number 1. This is going to need to connect to this rail support. And this is going to need to connect to... What are we colliding with? We're not colliding with anything. Well, maybe we're colliding with that. We're going to make it work. How about that? That works. Good grief. It's a good thing I've long since stopped caring about rail beauty, because this game is a bit of a mess. But, at any rate, we're all... Did I not connect these up already? Huh, I'm losing my mind. For some reason I thought we had already done... Oh, I think I disconnected it to move it up? I think that's it. Okay, there we go. Now they're all connected. Unsurprisingly, it's saying that there are no materials available. When we know that they are. So I'm going to do another save and reload. We'll see if that fixes it first before we start messing with rails. Oh, and we've got green, well, teal lights. That's a good sign. Here we go, awaiting items. So everything is now flowing towards the furnace. And then we have to deal with our output. So 1 rail support. And that needs to be brought all the way over to pole number 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? Yes. Pole number 8, rail connector, lower it by, well, 1, I guess. Storage depot at level. Output to... Oh, definitely not there. Output to here. You output to here. You output to here. And then you will be rail 1 of pole 8. There we go. So, let me set this to heat-resistant sheets? Heat-resistant sheets? I thought it was heat-resistant plates. We're still waiting on... Yeah, glass is being manufactured right here, so that makes sense. Hopefully the plates are moving, just they're coming from further away. I don't think they are, though. Nope, never mind. I was literally pushed out of the way by the Wolfram plates. We're just waiting on our titanium sheets. Here they are. Okay, the cavalry's all here. So our heat-resistant sheets are in the manufacturing process. I'm going to connect up these rails. And then we'll get these set up for delivery, and we'll be dealing with delivering 2 contracts at once. Yeah, for some reason the sheets are all piling onto the same rail. Because I guess because they're hitting a multi-connector there, so they're all redistributing themselves onto a single rail, which kind of defeats the point of a multi-rail. Ah, well. Okay, we didn't have any headaches getting those all run forward, so all of our rails are run appropriately. I'm curious. Okay, you can't run a multi-rail back into itself. Although I guess you technically could if you just did a rail support and then back into itself, but I don't know what kind of havoc creating a rail loop would cause when they're already barely functioning as is. Okay, so let's take a look. We've got heat-resistant sheets being manufactured. Now, normally, because this is a 4-second manufacturing time, this is rather slow. We can extend this line, put these through rail connectors and then feed multiple furnaces, which I will set up, but for right now, our extension this direction is actually being blocked by these orbital cargo launchers, so as soon as this contract is complete, we'll be able to destroy these and build some more furnaces that are all building our heat-resistant sheets, but for right now, we're going to have to make do with just one. There we go, rail connectors. So let's break this. Whoops. Take one. Are we going to be able to do this? We are. Yes. And we can do one to here. One to here. Very temporary because this is blocking the progress of our main bus here. But this is kind of the end of the line for this section, so then we're going to build 16 blocks this way, wrap these all into these 16 blocks, and then another 16 blocks this way to basically make a U-turn and head back in that direction. So let's set these up for delivery to Clever Robotics. And Clever Robotics.
Necesito agua.
Relax. I've got some right here. Oh yeah, we should, once this is all delivered, we should have access to the food processor so we can start making some higher quality food products. At any rate, all there is to do at this point is maybe go grab another batch of helium, but we're mostly just waiting for these orbital cargo launchers to do their thing, so I will be back up with you when these are ready to hand in. Okay, so I ran over here to pack my bags with a bunch of helium. I did want to check out what this valley is over here. It's very visually distinct from the rest of the map. Ugh, corrosion. How do we deal with corrosion? Is there something that we want in here? I see a bugaboo over there. Can we harvest some? Oh, we can. There's a harvestable resource here. Is this like sulfur or something? The sulfur fields? Can we hand harvest? Nope. Where is... somewhere in here there's a body, right? We saw on the map. Right here. It's gotta be like up against this tree or something. Nope. You're not gonna like this, but... where's the body?
Looks good.
Oh, what is this? Yeah. I'm out of there.
Detecting a caustic hydrogen sulfide gas. I recommend moving away from the
sulfur.
gas immediately.
So what were these? Soul Heart. Eat to gain effect. Gain 25 toxicity. That's all it does? Why would you want that? Also, where was the body? Body. Alright, we gotta go. Ow. Alright, let's go back to base. We have to be able to unlock a suit of some kind, I would guess. Or maybe our shields can unlock the ability to resist. Oh, here's a body. Our shields can unlock the ability to resist toxicity or corrosion. Thank you.
Order fulfilled.
All right.
From Future Health Solutions is waiting in the corporate terminal.
Let's claim our food station and let's get one set up here. Where? I'm not sure yet. Food station. Right here? How about right here next to the analyzing station?
Before eating raw food, you can now process and combine various nutritional materials.
I had something similar at home, but when my subscription ended, all I could make was algae bars and sourdough for borscht.
Oh no, this is not a simple food station. This one is
sourdough, though,
to the conditions on Arcadia 7. All the recipes it contains are designed with the local environment in mind.
So, no chance for a chimichanga? That was my favorite recipe.
No, but
space
I'm sure
chimichanga.
something from the food station's extensive menu will be to your liking.
I'm glad we were not the scientist guy for that one. He'd probably be something like, I don't need nutrition, I just need calories to fuel my massive brain. Okay, so... Oh, right, we have to unlock things. Come on. Just give me something. Let's see, poly snack we can make with poly fruit. Hydrolyte we can make with hydrobulb. So what's the multiple here? So a hydrobulb gives us 15 hydration. If we make a hydrolyte, we get 55 hydration. That's a multiple of almost 4. That's like 3.5, 3.6, somewhere in there. So I'm expecting a similar number for Polysnack. Actually, this is a bit worse. Polysnack is only 35 calories from 11. But it's still better than just eating these raw. Now, what else can we make up? There's a surprising number of recipes in here, actually. Oh, here we go. So the soul hearts that we found, they can be turned into soul bonds, which looks like fruit by the foot or fruit roll-up. And this says, increases max HP by 25%. Oh, interesting. Doubles corrosion resistance, drain resistance, infection resistance, and heat resistance. Does that stack? Health shards. It looks like powder. Energy boost capsules. Serpent sticks. Yeah, this says it does not stack. This does not say it does not stack. Interesting. So we can just load up on a bunch of honey stuffed Doritos or something and then just face tank a solar flare? 55, 50. What? That doesn't make much sense. You can spend... Oh, it's 4 hydrobulbs. Wait, no, that's even worse. You can spend 4 hydrobulbs to get 55 hydration, or you can spend 5 hydrobulbs and 1 serpent root to gain 50 hydration. Why would you do that? Oh, I see. It's output. So we only get 1 hydrolyte with this, with 4 hydrobulbs, but with the aqua bar we get 3 aqua bars. Okay, I get it. Aqua block capsules. Aqua chew. Aqua fluid. So what do we need to start unlocking these? Let's look at the recipe station here. So for hydro bulb... Oh, actually just need stuff. So we can actually unlock aqua bars already. We just need to insert 30 serpent root, 45 hydro bulb, and some research points. It says we have 30? I definitely don't think I have 30. I have 6. Unless I stuffed a bunch of materials here. Or consumables. I have 9 and 6.
I
have,
can use this.
Yes. I have 15 total, so I don't know about that. What else can we do here? We don't have 20 star tiers. We don't have 30 serpent roots. 80 polyfruits. These numbers are insane. 100. We haven't even seen these things. Oxalop. For pricklers, we can make figglers. 15 calories, 20 hydration. Do we have enough pricklers? You got 43. We don't have enough pricklers. I don't know why.
I'm detecting increased rupture.
That's fine, we're inside.
Prepare for a wave.
I guess it's just because we have them on us. Like it says 0 to 20 star fruit. Or star tiers. So if I grab our star tiers. Yeah, okay. So it's not saying we have enough to fulfill the requirements. It's just saying that we have them on our person. Got it. Okay. So, yeah, it seems like we're going to need a lot of more of everything. I'm going to put these back. I'm going to put these away. Survival food pack. Oh, it's just 3, like, juice boxes. We'll put the pricklers away. And we'll just craft up our hydra bulbs and our polyfruit for now. There we go. And hydrolite. Perfect. Hopefully that's a little more tasty than just eating raw plant bulbs off the vine. Who knows? We're gonna wait out this Ruptura, and we're really just waiting on Clever Robotics delivery at this point, though I may go and reassign the launchers that we just got done using for future health to kind of double up on this Clever Robotics delivery, but we can't do anything until this sun explodes, so we'll see in a second. And let's see, how far away is titanium housing? It is actually worth the exact same amount as heat-resistant sheaths, despite being significantly more difficult to manufacture. So let's see. Well, not significantly, but slightly more difficult to manufacture. Yeah, we can actually just loop this. Get rid of this. Not habitat, but rail. Loop this right into here. And we can tell these guys to all start delivering titanium housings. And this should speed this way up. Perfect.
Congratulations.
There we go.
Clever Robotics has received its order. A reward for fulfilling the order is waiting for you in the terminal.
So this is Rail version 2, which moves 240 items per minute, compared to our existing Rail V1, which moves 120, so it should be twice as fast. So to test that, I've set up this little test arena over here. Between these two pairs of storage depots. Hello? What are you doing here? Why are you here, little drone? Can I grab this? No. Anyway, first off, I put 2 Rail V1s between these two because I wanted to see if these can be upgraded in place. They can. That's going to make this much easier. Okay, so we have titanium bars and wolfram bars. So if I set these two storage containers to the same thing, so we have titanium, we have wolfram, these should attempt to load balance, and we should be able to see, oh yeah, just how much quicker these are going to be moving along. Now we're not at the level of manufacturing demand yet. There does seem to be some bugginess. The drones seem to be, for like 1 frame, they seem to be clipping off the rail. But we're not at the level of manufacturing throughput that we necessarily need much faster rails. I think the only real benefit we're going to get out of this is considering the length of our main bus here. We're going to get items being delivered from the far side of the bus to the near side of the bus, and half the time it takes the current rails to do it. But it's not like we're pushing a huge amount of materials down this bus. Like, our rails are about 70% empty. Things are just kind of moving along lazily, so we're not going to get a huge advantage out of that yet. Maybe if I redo this main bus to be more space efficient, because a lot of this is just empty rail space for stuff that we don't have on the bus yet. So that can be pared down a bit. We could space optimize this, build it out as we move forward instead of building out to the full width at the very beginning and using all 16 lanes through the entire bus. But there's a lot of things to experiment with. Maybe we can find a way to take advantage of multi-rail connectors acting as kind of load balancers. Although this format really does benefit the most from having everything on its own individual rail. But who knows, there's a lot of stuff we can play with. But all of that is for future episodes, because that's going to be it for this one. I do have a little platform set up over here. We're going to do the outro to this one standing on there so we can look out over kind of the entire stretch of our main bus that we've assembled here. So give me just a moment. And there we have it, our huge manufacturing monstrosity that required kind of paving over paradise, as it were. But it does save a lot of the kind of kludginess of having everything smashed together in a really tight space and having to wind rails around manufacturing buildings and through things and intersecting with other rails. Now, this does have its own set of challenges, which we've experienced plenty of in this episode, but hopefully those will be cleared up in future patches and bug fix updates. But for now, it's mostly workable. So in the next episode, we'll have to work on getting drone delivery unlocked so we can fly in Helium from our secondary base over here on the far side of the mountain. We'll get these rails upgraded to Mark II. We'll serpentine and do a U-turn for the next leg of our manufacturing bus and kind of bring it back towards our calcium extractors here just to add some more manufacturing capacity on. And I still want to work towards this big monolith out here in the distance. But we're going to have to do some more adventuring and probably unlock some more environmental protections, because I doubt we're going to be able to just walk right up to that thing. So yeah, that's where we're going to leave off for this episode. So if you're enjoying this playthrough of StarRupture, hit like and subscribe. If you want to check out StarRupture for yourself, head on over to Steam and pick it up. And if you want to let me know what you think of the game so far, then hit the comments down below. But whatever you do, I'll see you right here again in the next one. So, until then, bye-bye.